I'm back for the HL stuff. And a little disclaimer, I have looked through the exam ahead of time, unlike the SL ones, which I generally just jump in blind. And this is just for the sake of time. HL stuff takes a while, even for me, especially if I'm doing it blind without really studying, or at least reviewing the content. And also, I'm only going to be going over the HL specific things because there are questions from the SL exam that are also going to be in the HL exam. So why don't we get started? For example, here, this one's in the SL exam, so go watch that video. So is this one. So is this one. And so is this one. So the first HL thing is this vector question. Okay, which is right here. So what we need to do is show that the magnitude of the cross product when you square it is going to look like this. So a couple of things. One, you should have your formula booklet, and then take a look at what we have for the cross product. And the one that should jump out to you is this one, just because it does have the two magnitudes of the vectors that we have, kind of like this side over here. So I'm gonna work with that. And then my pen is being really oddly proportioned right now, so my writing might look a little wider than usual. Okay. And then this is just a geometric interpretation of what the magnitude of the cross product is. It's the area of the parallelogram between them. So if you had like A and then you had B, they can make a parallelogram. And then we know what the area of the triangle is. It's 1/2 length of A times length of B times sine theta. So then the parallelogram is just twice that much. So the 1/2 and the 2 just cancel out. So that's where this formula comes from. Okay, and then we're just gonna play with it. So we need this to be squared. And so we square this side. And then I'll have length of A squared, length of B squared, sine squared theta. Okay, so this looks pretty good right here. And then if you look on the other side, we need a scalar product, dot product. So again, if you look at your formula booklet, we're gonna scroll, well, you're gonna look up, and then right here is the dot product or scalar product. And notice that it has a cosine in it. And what we have right now is we have a sine squared. So we're actually going to use the Pythagorean identity. One minus cosine squared theta. Because if I change this into cosine, then I'm probably going to be able to manipulate this around so that I can get the dot product, because it needs a cosine. Okay, and then yeah, this looks almost done. We can multiply these in. So we have our first term set, which is good. And then minus A squared, B squared, cosine squared theta. Okay. And then this is literally the scalar product to the power of 2. Yeah, because each one of these is going to be squared. And then you're done. Oh, oops, I'm not supposed to write that one. This turns into A dot B squared. All right. Okay, next one. I think this one was in the SL, so I'm gonna skip it. Okay, so that means that the next one is this one. So copy, paste. Okay. So we have a cubic equation, and then it has the three roots a, b, a plus b, and then they also give us this, and then we need to find the value of k. Okay. So I think we are going to use Vieta's formulas. So that is from topic 2. These ones are here. So if you have a cubic, then if you sum the 3 roots, and then, well, first off, the leading coefficient is 1. So then in this formula, an, which is the leading coefficient, doesn't really matter. So the second coefficient, this k, should be the sum of the 3 roots, because this negative is for that negative. So I know that alpha plus beta plus alpha plus beta, I guess I should write this properly, alpha plus beta plus alpha plus beta. So if I add these 3 roots, they should be the second coefficient, which is k. And then we also have the product formula, which is this right here. So my constant term should be the product of these 3. And then it's to the power, well, like times -1 to the power of 3. So we have alpha times beta times alpha plus beta should be equal to -3k. Okay. And then we need to solve for k. So I know, given this, I can do a substitution right here. So -k squared over 4 times alpha plus beta equals -3k. And then from this one, what is this anyways? This is 2 alpha plus 2 beta equals k. Okay, so what we can do is, from this given, I make the substitution, and from this equation, I'm gonna make a substitution here. So showing all my work, if I take out the 2, and then I can divide by 2, nice. So I can make that substitution here. Okay. So I'll have, I'm gonna ignore the negatives. So I'll have k to the power 3 over 8 is equal to 3k. I don't like denominators, so I'm gonna multiply this over. And we're just gonna keep solving for k. Okay, so either k can be 0. I don't think it can be 0 from the question. Yeah, because k has to be a positive number. So let me just remind myself of that. So that means that k needs to be root 24. Alright. And then, ooh, vector question. That's definitely HL. Okay, we have two lines. Here are their equations. So here's my position vectors, my direction vectors. Show that L1 and L2 don't intersect. Okay. So there's a couple ways that we can do this. We can set them equal to each other and then solve the system, which is probably what I would do just right away if I didn't think about it some more. And then if you do, you'll find out the system is inconsistent, which means that they don't intersect. But if you notice, their direction vectors are multiples of each other. So 2, negative 2, 2 is basically 2 times the other one. 1, negative 1, 1. So they have the same direction vector. So at least right now, L1 and L2 are parallel. Okay, so all that means is that their position vectors, they should be a difference of the direction vectors. So, or well, okay, if they're, let me rephrase this. We know that they're at the very least parallel. They could be the same line, and then if they're the same line, then that means that this position vector right here is going to be this position vector, or vice versa, plus or minus, you know, some scalar multiple of this. So again, if they're on the same line, then for example, if you called this U, and then this is point A, and then this is point B, so we know that they're parallel. If you want to show that they are the same line, then these two position vectors, which you can consider as coordinates on the line, they should be some scalar multiple of the direction vector away from each other, like the difference between them. And then if they're not, then that means that they're two different lines. So they are parallel lines and not the same line. So what I can do is I can just do A minus B, find the difference between the two. So 3 minus 2 is 1, 2 minus 0 is 2, and then negative 1 minus 4 is negative 5, I think. And then this is very clearly not a multiple of the direction vector that we want. And this is not some multiple. Oh, that looks really weird. Negative 1, negative 1, 1, negative 1, 1. Okay. So the difference between them is not a multiple of the direction vector. So that means L1 and L2 don't intersect. So they are parallel. Okay, and then I'm gonna fix this then. L1 and L2 are parallel or incident. I think incident is the word you use when it's the same line. And then this comes from the fact, again, that they share the same direction vector. Okay, next up, find the minimum distance between L1 and L2. Okay. So if here's L1, and then we know L2 is parallel, so the minimum distance is going to be the length of a perpendicular line between them. And then this is going to be the same distance regardless of where you are, because they're perpendicular. So what I'm going to do is I'm going to take this position vector on point 1, or on line 1, so 3, 2, negative 1. So 3, 2, negative 1. And then the opposite side to it is going to be some expression. So it's going to be 204 plus some multiple of the direction vector. So 204 plus, I don't know, I'm going to use a different variable. I'll call it m. And then, oh, it's m times 1. And then the middle one was negative 1. So this is negative m and then m. Okay. Yeah, okay. So for some scalar multiple m, I'm going to have this coordinate, and these two coordinates together, again, what is this? I'll call this A, call this B. So then the vector AB, or BA, I never really remember the order of these, we're going to subtract. So I'll have 3, I'm going to take B minus A, which I think is AB. So 2 plus m minus 3 is negative 1 plus m. 0 minus m minus 2 is negative 2 minus m. And then we have, I think, 5 plus m. So 4 plus m minus negative 1. Okay, nice. So here is vector A, B. Okay, now shortest distance means that this vector AB needs to be perpendicular to any of the two direction vectors. So that means I have AB and then if I take the scalar product with the direction vector 1, negative 1, and 1, this needs to be 0. And then from here we can solve for m. So taking the dot product, and you guys are HL, so I'm going to skip some of the more obvious things. Here is the expression for the dot product. Okay, and then what does that mean? We have 3m, we have 2, 5, minus 1, so plus 6 equals 0, so m is negative 2. Okay, and then what do they actually want? Find the minimum distance. Okay. So this means that if m is negative 2, my point B is going to be 2, negative 2, negative negative 2, So this is my point B. And then that means that the length of AB is going to be the square root of, okay, 3 minus 0 squared, which is 9, plus 4 minus 4, and then negative 1, also 1 plus 4 squared, which is 25. Square root 34, something like that. Again, you guys are HL. I'm just using the distance formula between 2 points. I hope I'm doing it properly. Okay, so that one's done, I think. And then let's do this one. Okay, that didn't make that sound before. Can I turn that off? Sorry. Quick preferences. Effects. No. Oh wait, no, I think that's a Windows notification. Whatever, okay. Just gonna live with it. Okay, using U substitution, solve this integral. Okay, so that means that du is cosine dx, so we have u du u squared minus u minus 2. Okay. And then every time I see a quadratic, I just factor it, especially if you can. Okay, and then I think we are going to do partial fractions. So u minus 2, u plus 1 is equal to a over u minus 2 plus b u plus 1, and then that means that u is equal to a times u plus 1 plus b times u minus 2. So again, I'm just multiplying all of this by this denominator on the left side, and then, you know, some factors cancel out, and then I'll end up here. Okay. So I have u is equal to au plus a plus bu minus 2b. Okay, so comparing coefficients, I know that 1 is equal to a plus b. And then at the same time, a minus 2b is going to be 0 because there's no constants on the left side. Okay, so a is 2b, which means that this is 2b plus b equals 1. So b is 1 over 3, which means that a is 2 over 3. Okay, which means that we can split up our integral into 2 over 3, 1 over u minus 2 du plus 1 over 3 1 over u plus 1 du. At least I think that was it. Yeah. Okay. And then taking the integral of these, we got 2 over 3 natural log of u minus 2 plus 1 over 3 times the natural log of u plus 1 plus c. Okay, and then I mean, there's a lot of things you can do. How far do they want me to go? I'm just gonna replace these with whatever they were originally, sin x. And then hope that that's an appropriate answer. Actually, let me pull up the mark scheme right now. Because like you can further simplify it using like log laws and things like that, but oh, here we go. Yeah, okay. Condone further simplification? Actually? What? Man, okay, sure, fine, don't simplify it more. Okay. Oh, and then nice, section B. So this one is an SL question, so go watch that one. And then the last two are HL questions. Okay. Okay. We have acceleration. Positive time, okay. Here is a, sure, for -1, okay. At t equals 0, particle is at a fixed origin, initial velocity v0, sure. By solving an appropriate differential equation, show the particle's velocity is given by this. Okay. So, we know from, basic calculus that A is dv dt. So this -1 plus v. And then if we want to find the velocity, we can take the integral of this. Oh, well, okay, that's not really proper, whatever. But we're trying to solve this differential equation, which they even tell you to do. So what we can do is do a separation of variables. So I have dt on this side, and on the other side, I'll have 1 over -1 minus v dv. Okay. And then taking the integral of this, that means that I have t, and then I'll add the constant on this side. Then on the other side, I have the natural log of -1 plus v. Right? Is there a negative in front of this? Here. There we go. Okay, and then what do I need to do? Oh, I need to show this. So I need to get an expression for v, this expression. Okay, so first I need to deal with the absolute values. But if you notice, it says here v is more than -1. So this is always positive. So this doesn't really do much, the absolute values. So I have negative natural log 1 plus v equals t plus c. And then there's no constant, so we're going to need to find the constant, probably using this here. Okay, so if t is 0, then you have this on the right side. The velocity is going to be considered v naught. Alright, so then this is my constant. And I don't really see that in here, but maybe we'll deal with that when we get there. Okay, so now I need more room. Okay, so what do we got? Okay, so this becomes this, and then we are going to solve for v so that we can get a function of v happening. Okay, so first take care of that negative. So the second term becomes positive. I'm just going to write at the front. T becomes negative, so I'm going to write it as the second term. And then this means that if we raise these to the power of e, these are inverses, so I'll have 1 plus v is equal to e to the power of natural log 1 plus v naught minus t. And then I need to make it look like this. Okay. So if I move the 1 over, I get that -1 that we need. And then if you notice, there's only e to the power negative t, so we just want this. And so what we're going to do is use exponent rules. And this is the same as this e multiplied by e to the power negative t. Because yeah, these are the same base, so we would add their exponents together like this. So we can do the reverse and split it up. And then again, same thing, these are inverses of each other. And then I think we're done. We get v of t. Okay, yeah, that looks good. Okay, and then initially at this origin point, the particle moves in the positive direction until it reaches a maximum displacement from O, then the particle returns to O. Okay, S is going to represent the displacement, S max is the maximum displacement from the starting point. Show that the time capital T taken for the particle to reach the maximum satisfies this equation here. Okay. So we're gonna use this from part A, and we want to show that we have max displacement at time t. So using calculus, this is basically an optimization problem. The maximum displacement is going to happen at when the derivative of the displacement is 0. So ds of dt, which we know is v, is 0. Okay, so that means I'm going to plug in capital T. So I got 1 plus v naught e to the minus big negative T minus 1 is equal to 0. And then I need to show this. What am I trying to show? Okay, e to the t is this thing. Okay. Oh, yeah, okay. So from here, we can move the 1 over. And then if I just multiply both sides by e to the positive t. No, let me change colors. Then this one's going to cancel out with that one multiplies there, and then we're done. We'll have 1 plus v naught is equal to e to the big T. Okay, yeah. Then by solving an appropriate differential equation and using the part from this, find an expression for S max in terms of v naught. Okay. Okay. Copy. Paste. So we need to find an expression for the displacement. So here's an expression of the deselect, whatever, of the velocity. So if I take the integral of this, I should get the displacement. So this is going to be, what, negative 1 plus v naught e to the negative t minus t plus c. Okay, and then I think I need to find C. So I know that at the beginning, I think the displacement's 0. So I'm gonna have negative 1 plus v naught plus C equals 0. So C is equal to 1 plus v naught. Again, I'm plugging in 0 for t, so this is just 1, and then this is just gone. Okay. So that means that I have this as my function for S. And then I need to find an expression for S max. So I know S max happens at capital T. So I got 1 plus V naught at e to the negative t minus t plus 1 plus V naught. And then I need to use this thing somewhere. Okay. Right here, right? Yeah, okay. So I'm gonna make a substitution here and not here because I think the question wants me to have it in terms of V naught. So I shouldn't have capital T's anywhere. So what I'm gonna do is, using that part B, I know that this is e to the t. This is e to the negative t, I have minus t, I have 1 plus V naught. And then these cancel to be 1. So I have 1 minus t plus 1 plus V naught. But what about this capital T? Did I mess something up? Okay, take the integral of this. You get this plus c, plug in 0, 0. You get this. Bring that over. So this is your displacement. Plug in big T to get the max. And then I have a capital T still. Uh-oh, where'd I go wrong? Okay, time to look at the mark scheme. Okay. Yeah. Oh, I'm so silly right now. Oh, it's okay. I just need to write this in terms of V naught because I know from this thing, right? Okay, so I'm going to do that right here. So this means that t is equal to the natural log of 1 plus V naught. There you go. That was dumb of me. So S max. 1 minus natural log 1 plus V naught plus, well, okay, this one and this one are going to make 2. So I guess I'll write 2. There you go. Okay. Let v t minus k represent the particle's velocity k seconds before it reaches S max. Sure, okay. Using the part from BI, show this. Okay. BI, what was BI? This thing? Okay, I'm just gonna copy the question again because I don't want to keep scrolling up. Okay, so v t minus k equals to 1 plus v naught e minus t minus k minus 1, and then I need to show this, and then I'm going to use this. Okay, yeah, we're going to do the same substitution. So this is e to the positive t. And then this negative, I'm just going to multiply in. So you got minus t plus k minus 1. And then these guys are going to cancel out. So you're just left with ek minus 1. Easy. Okay, similarly, k particle velocity S max. Deduce a similar expression in terms of k. Okay, so we're doing the same thing. Well, okay, I'm just gonna copy this then. So this is plus, which means that this is plus, which means that this is minus, and then this is negative. Okay, and then we're done. And then E, hence show that this plus this is going to be positive. Okay. So we're going to add these two things together. So EK, adding these together, plus E negative K minus 2 is greater than 0. Okay. Is there any way to show that this is more than 2? Oh, I think I remember this. Okay. Okay, so I need to show, like, this is true no matter what k, right? Yeah, no matter what k. So if I were to graph this, I need to show that this thing is basically always above the k, well, whatever axis you want to call this for k, and then, I don't know, g or whatever. Okay, I don't want to think too much about this. I'm going to Mark's scheme. Express as a square? Oh, I guess. Who would see that though? Okay, what's the second method? Okay. Wow. Okay, that's a hard question. So let me explain both ways. I would never think of the first way. So to show that something's positive, if this side is a perfect square, then it's going to be positive, which this is. but I would say that that's incredibly hard to recognize. This is ek over 2 squared minus 2e to the k over 2 times e to the negative k over 2 plus e to the negative k over 2. And then this is a perfect square, because this is just e k over 2 minus e negative k over 2. And then being a perfect square, it's always 0 or more. But who would see that? That's crazy. I like the other way. So what we're going to show is we're going to show that the minimum is a positive g value. Because if the minimum is positive still, then it only goes up. So what we do is we take the derivative of this. I guess I'll call it g prime. Because then you'll have ek minus e negative k. And then we're going to solve this for 0. So we have ek is equal to e to the negative k. So k is equal to negative k. And then the only k where that's possible is 0. Okay. So this is a critical point. So we don't necessarily know that it's a... We don't necessarily know that this is a minimum, but essentially this is talking about velocity, right? Yeah, g is 2 velocity functions, so this is still technically a velocity. And then, okay. So remember this, we have acceleration. And for the values that are given for the velocity, if v is always -1, then 1 plus v is always positive, which means that the acceleration is always negative. So v is always more than -1, which means that a is always negative, which means that this critical point is a minimum because your velocity is concave down, because your derivative... Wait, no, hold on. That's not how it works, is it? Or is this position? Shoot. I'm getting my things mixed up. Wait, I don't know if I can say that. Like I said, I don't want to spend too much time on this. I've already spent under an hour, but I got more. Minimum value of 2. So this. Oh, they don't even justify that's a minimum. Okay, whatever. So this means that g at 0, well, not at 0, but for k equals 0, vt plus k plus vt minus k is going to be... Oh, that's so weird, but okay. 0. Because this is going to be e to the 0 minus e to the 0 minus 2. Okay, let's see if that makes sense. Yeah, okay. There's going to be a minimum for this when k is 0. So when we plug in k equals 0, we get that the minimum value is 0. And since this is the minimum, then it only goes up, however it wants to go up. Okay, that makes sense. So whatever they said is always more than 0. This thing is always more than 0, because the minimum value is 0. Okay. Tough question. I hate HL exams. Okay, next one. This is the last one. Okay, we have diagram of Arctan. Okay, describe a sequence of transformations that will transform Arctan into this. Sure, easy enough. So we have a +1, a ×2, and a plus pi over 4. So we have a horizontal translation, -1. I'll just say left 1. I have a vertical translation, up pi over 4, and then I have a horizontal stretch by 1/2. Okay. Then I need to show arctan P plus arctan Q is this identity, P plus Q, 1 minus PQ. Okay. I don't think there are any inverse formulas, so I think we need to use this identity. Yeah, you can kind of see it in here, over here. Okay, so arctan is the inverse, so these are my angles. So let's see. That means that if I tan both sides, P plus Q, 1 minus PQ. Okay, let's see, what do we do? Well, those cancel. Tan A, tan B, tan this. Okay, hold on. this is kind of ugly, so let's do it this way. Let's call this A, because this is an angle A, and then this is angle B. Okay, let's try it this way. So then tan A plus B, and then we can literally use this identity. Oh right, because this is an identity, so I shouldn't have tan both sides. And then so we literally have this. Tan A plus tan B. 1 minus tan. Okay, yeah. Okay, this was easier than I thought it was. Okay. Because from here on the right side, tan A is literally defined as P because of this relationship. This one is Q, then I have 1 minus PQ. Okay, and then I just have to arctan both sides. So, or well, this by definition means that A plus B is equal to arctan P plus Q divided by 1 plus 1 minus PQ. Yeah, okay, yeah, so inverse. And then again, A plus B we said was these two. Okay, nice, done. Then verify that this is equal to that. Okay. So we're going to probably use that identity. To show this. Okay. So we're going to use this identity. And here's our first arctan, and then we need to get the second arctan. We have the angle pi over 4. So pi over 4 is arctan of 1. And again, as HL students, hopefully I don't have to explain why that is. And then from there we can use the identity in this question. So this means that this is equal to arctan x divided by x plus 1 plus 1 1 minus x minus whatever. Yeah, I don't know. Do I need to explain it? I don't need to explain it, right? You guys should know that pi over 4 is arctan 1. Okay, and then if we simplify this, we'll probably get 2x plus 1. Okay, let's see. So we'll have x plus 1 so just doing a little bit of fraction math, common denominators. Okay, adding my numerators, and then these are gonna cancel. Aha, so then we're done. Yeah, just some manipulation. Nice. And then am I done? I don't think I'm done. I think I didn't copy one of the questions. Here. Okay, I'm gonna copy the whole thing because it says I need part B. Oh boy. Now I need to use mathematical induction. And the result of part B, this part. Okay, mathematical induction is easy. So first thing is we need to find the base case. So when n is 1. So is, on the left side, arctan of 1 over 2 equal to the arctan of 1 over 2. Yes, it is. Yes. So assume true. I forgot the real formatting. Like, there's a specific way to say this stuff. So assume that this is going to be true up to some k. Some k value. Then let's check out what happens when we do k plus 1. So we'll have the sum k plus 1 of arctan 1 over 2 r squared. Okay. Okay, so we need to have our assumption. Oh, I should write the assumption. So this should be equal to arctan k plus 1. Okay, so here's my assumption, and then this is summation, so it's easy for my assumption to show up. I just split my summation into k and then the k plus 1 term. So arctan 1 over 2 k plus 1 squared. Okay. And then from my assumptions, I know that this is going to be whatever I said it was, this thing. And then if I add that to this thing, and then I need to use my result of part B. So I'm going to use this identity again. So okay, so by part B, here we go. I'm going to use a lot of copying and pasting. So this plus this over 1 minus okay, using that identity I have this, and then if I simplify it, it should be whatever it needs to be. Okay. Oh boy, here we go. So arctan Jesus, okay. 2 Okay, I think if I add these, I'll get this. And then on the bottom, what even is this? Okay. I don't like the way that this looks. Okay, well this is just a matter of simplifying things. I don't even know what I want it to look like. What am I supposed to make it look like? Okay, k plus 1 over k plus 2. Okay, this thing needs to be k plus 1 over k plus 2. Yeah. Don't really see how that's gonna happen yet, but okay. Okay, stop being so lazy. So that. And that. And then that goes there. Okay, I'm taking the reciprocal and multiplying, and then this will cancel with this. And leave me a k plus 1 over there. Do I really gotta expand this out? Man. I don't want to do this. You know what? Time to check the mark scheme. Okay, where is this thing? This, that, this. See, look. Okay, look. You have to do this. You have to do that. This is where I'm at right now, this step. You have to expand out the cubic. I don't want to expand out the cubic. And you have to factor the cubic. And then these cancel out so that you get what you want. That's so stupid. That's so stupid. Okay. So here, we're gonna go through it a tiny bit. So you expand this out, and you can just use Binomial Theorem to expand it out rather quickly because it's a cubic. And then again, this is all inside the Arctan. And you're supposed to make this be k plus 1 over k plus 2. And I guess the big hint that you know it was factorable is that we already have the k plus 1 part. So that means that down here, after you simplify the denominator, it's kind of giving you a hint that you should be able to factor this k plus 2 out, and then you'll have a 2k plus 2k plus 1 in the denominator, which will cancel out with this one, so that you are happy. But I don't know, that's kind of annoying, but such is the HL life. The last time I did one of these blind, because there was no mark scheme yet, I spent like, I don't even know, half an hour just algebraically manipulating something. And I'm not going to do that here, especially not when there's a mark scheme. So let's go through this and see how well I did. I mean, to be fair, I already ran through the mark scheme, so it should be fine, but you never know. Okay, so the first question is this one. So this one was a general proof, so that was done, and that's correct. This one was an SL question, and then here, nope, that's the second way to do that one. Ah, here, okay, so the Vieta formula one, this one. Find the value of k. I got root 24. Root 24. Okay, so that's good. Let's see, this one. This is the two parallel lines, so I showed that they're not going to intersect because they're parallel. I need to find the minimum distance between L1 and L2. I got root 34. And they got root 18. That's not even close to what I got. What the heck? Did I mess up? Okay, they got the -2. So 2 minus 2 is 0. 2, 2, 2. No way. I might have messed up the distance formula. Okay, 3 minus 0 squared is 9. 2 minus 2 is 0, square that is 0. And then -1 minus 2. Oh shoot. -1 minus -2 is -3, so when you square that, that's 9. So this should be 18. And whatever. Okay, this one. Oh yeah, I checked the answer to this, so this one was right. This one was a lot of showing stuff, right? Yeah, this was a lot of showing stuff, so this is all correct. And then I checked the answer for this one, showing this is greater than 0. Man, that was such a hard question. I think this is the hardest question in the exam. And then transformations. Okay, horizontal stretch by 1/2. Do not allow compression? No way. Why don't they let you use the word compression? Uh-oh, okay. I better warn my students about that. Okay, followed by... Oh wait, here you go. I want to translate it left one first. So left one, scale factor 1/2, vertical translation upward. Easy. Okay, this is a proof, this one's a proof. and this one's a proof, so we're done. Jeez. Well, there you go. And that still took me, even with going through the mark scheme, even omitting the SL questions, freaking an hour and 20 minutes to explain. This is why I don't like doing HL stuff, but kind of have to for my kids, and I guess by extension you guys. Oh well. Okay, next up is paper 2, time zone 2, May 2021. And then also paper 3, and then also time zone 0, the November exams, papers 1, 2, and 3. Although your exams are like on Friday, so I don't know when I can squeeze this all in, because even if I did it 1 a day, and I don't really want to do 2 a day. Whatever, I'll figure it out. If it doesn't get uploaded in time, sorry. See you guys later.